The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
What's wrong, Allison? It looks like you're having a bad day.
Yeah, I'm having a pretty bad day. It's just all of my friends already know what's happened in Game of Thrones and I don't have HBO.
Well, would it cheer you up if I did some impressions? I know you always like that.
Yeah, that might lighten the mood a little bit. How about a classic, The Emperor?
Oh, from Star Wars?
If you spoil Game of Thrones for me, I will throw you down a pit and you will die.
That's pretty good.
Good.
What about some of the newer impressions you've been doing, like Dave Jones from the EEVBlog?
Oh, right. Let's see. Dave Jones from the... Of course, you got to go, hi, it's the EEVBlog. Dave's got a lot of great quotes. I was thinking, what if we took one of these things that makes silly barn animal quotes? I guess they're not quotes, they're more like sounds. Why do I care what the mouse says? I'm not 5. But we could make this into a Dave Jones quote soundboard. You select a photo of Dave Jones, pull the lever, and he says something like, beauty.
Yeah, that sounds like a good project idea.
So what we'll do is take it apart, figure out how it works. We'll probably have to replace the electronics with our own to make it do our custom quotes, but we can probably still use the 3 AA batteries on the back. And then we will scan this and replace it with custom photos of Dave Jones. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
Let's take apart the CNC and see what's inside of it. Do you say? By the dawn's early light. Sorry, couldn't resist. Much faster. All right. Batteries here. Speaker. Let's go a little deeper. It's like all the circuitry is on the button matrix here. Don't turn it on, take it apart. That's what Dave Jones would say. Hey, doing Dave Jones impressions is appropriate because this is the Speakin' Jones or whatever we're calling it. Okay, so this is the whole circuit. There are 10 buttons plus a switch because you can switch what animal you're on or group of animals. So 11 buttons total. And it looks like what happens is when you pull this lever, see how this clutch rises here? That rises up and it's kind of hard to see. It's like it's milky white, but right there, that piece comes up and it pushes one of these buttons. And that is dictated by where the arrow is. So when I move the arrow, it moves that button around. All this mechanism really does is push one of 10 buttons. I believe the old versions of these, it actually had some sort of it was all mechanical, there wasn't any electronics. So when you pulled the string, just like, a talking doll, I don't know exactly how it worked, but if I had to guess, there's probably some sort of plastic disc that had grooves in it, and when you pulled it, basically you were manually winding a record. It probably wouldn't have been magnetic because that would have required electricity. But of course nowadays everything is electronic, so it still has that mechanical feel of pulling the lever, but all it does then is push one of these buttons. It really pushes my buttons. Silver marker, mark the orientation. Probably use this, so I'm not gonna throw it away. Okay. Yeah, they've got some weird matrixing going on, probably because pushing the button also activates the circuit. So what we'll probably need to do is make our own circuit board that matches this design and embed it in place. This is that's a glop top ASIC. Glop top means they just put a bunch of epoxy on it. ASIC is an application specific integrated circuit. And what they do in these cheap ones is they actually will put the silicon right onto the PCB, so there's not even a package around it. It's just, you know, the raw silicon with epoxy over it to protect it. It's not even a chip. For starters, I'm going to rebuild this circuit board. In our next episode, we're going to cover a lot of cool ways you can make your own circuit boards. So I'm going to use one of those methods to reproduce this. Here is the replacement PCB that we made. And I actually cut the FR4, which is what the PCB is made out of, using my laser. So not only did we use a method called laser paint to actually trace a circuit, but we use a laser to cut the shape too, so it will fit right in place of the old one. Beauty. I'm gonna wire up my custom ring of buttons. I have to make sure it stays nice and flat because there's not a lot of room. See these indentations back here that this is gonna mate to? So I've got this ribbon cable and I'm going to strip it apart like this so I can make connections very tight. Then this piece bolts in place, but I've hot glued it in place for now just so I know where it's going to be in relation to everything else. So I'm going to thread my wires through. And I'm not necessarily going to go in the right order, you know, 1, 2, 3, 4, 5, 6. I'm going to go in the order that's easiest to thread. So see how I go on the outside there, then this one will go here. Because there's less room on this part of the project than on other parts, so this one I wire efficiently, and then if the wires aren't necessarily in the perfect order, you know, I've got more room to deal with that over here. So see, I'm just going right down the line, because if the wires don't overlap each other, then they stay flat. I even drilled a little hole in here and I dremeled a groove so that wire, see, can stay flush and flat and not much thicker than the yellow piece itself. And once I have it in place, I'm gonna put a little hot glue on it just to hold it there. Always better to use too much wire than not enough, because you can always trim wires down, but it's not super easy to make them longer. So this part is probably going to come over here and I'm going to put a disconnect on it, so I will cut him off right there. All right. Now I've just got to wire these to the copper traces. It's just fun to impersonate Dave Jones. What can I say? Unbelievable. I wish I had a cool accent like that. I just had this dumb Midwest accent. Yeah, hey. All right, we have that side done. It lays flat. Now time to do the other side. Her name is Scully. Seems like it will work. I want to test that it's actually making contact. So I'm going to fire up my multimeter. Multimeter. I'm going to attach some disconnect headers just so it's easy to put this project together. For the night is dark and full of spiders. I think you need to bone up on your Game of Thrones mythology. Here are the rubber contact domes. I've put them onto my custom circuit board. I need to make sure that they work. Okay, they work if I press it, but I need to make sure they work in the wheel. Let's try it out. There it is. All right. I can bolt this in place and leave it as is. And then we'll attach the next part of the circuitry in this area. Now it's time for a tech timeout. Later on in this project, we're going to need a voltage regulator to take the 4.5 volts that we get from the 3 batteries and knock it down to 3.3 volts so we can use it with the microcontroller and the SD card as well. SD cards are almost always 3.3 volts. So I thought it would be a good time to talk about dropout in voltage regulators. Now you have a voltage regulator, something like this, maybe like a TO220 package. You have a voltage coming in, let's say 5 volts, which is pretty close to what we're going to be using. Then you have ground, and then you have out. And the output is going to be the regulated voltage that you want out of your voltage regulator. So let's say this is your 5 volt here, and your 3.3 volt, that's what you get. And there's a distance between it. Now there's something called dropout on a regulator, and that is when the input voltage gets too low, even if it's still above the output voltage, at a certain point, it will drop out and cause the output voltage to basically fail. And that is the dropout point. That will be listed in the data sheets for your regulators, so you should obviously read that and find out what it's going to be. So in our case, 3.3 volts to 4.5 volts, it's a pretty good distance, but as those batteries get weaker, the 4.5 volts will start to drop. And once they get too low, then the 3.3 volt output will fail. One way you can hedge your bets is to get low dropout regulators, or LDO regulators. That's pretty much the only kind I ever use. So that the distance between these two voltages can be more narrow. So this voltage can get a lot lower before your output voltage will fail. It wasn't all that long ago that the migration from a low-cost 8-bit microcontroller to a 32-bit solution seemed Herculean. But with today's 32-bit solutions based on ARM Cortex-M and growing ecosystem of development tools, those barriers are a thing of the past. Priced competitively with 8-bit microcontrollers, ARM Cortex-M devices offer jaw-dropping performance benefits. Now developers can use one set of tools, regardless of the manufacturer, and switch to silicon as needed without the penalty of new learning curves. And if performance and price weren't enough, developers now have access to a host of tools, such as Mbed for Freescale and NXP, Cocox for ST Microelectronics, and Energia for Texas Instruments. And they're all completely free! So if free tools, low cost, and high performance are your thing, why wouldn't they be? Be sure to check out element14.com for more details and learn how 32-bit products can help you on your next build. Dave Jones was kind enough to send us some authentic sound samples from his show. There's quite a few of them. So I've taken some of his key phrases and put them in the timeline here in Adobe Premiere. So we have Dave Jones saying things like this.
Ancient, average, 30-year-old technology.
And of course, classic lines like this.
Don't turn it on, take it apart.
So I have two groups here of 10 because there's two sides of the speak and see and say. Why do I keep saying speak and say? Oh, I think speak and say was like one of the speak and spells, because there was speak and spell, speak and math, and speak and say. Yes, and I did have one of those as a kid. I probably had the barn thing too, I just don't remember. I mean, that was way too long ago. All right, so I have basically 20 different sound clips that Dave Jones is going to say. And I guess he says things like this too.
Spectacular transistor hardware, give it a go.
So what we're gonna do with these clips is we're gonna export them as a series of files, and I'm going to use the same file system that I have in my pinball machine because it works. Basically, we're gonna have two folders. There's going to be a folder called FA and then FB, and one folder will have AA0 through AA9 sound effects, 10 sound effects, and the other folder will have BA0 through BA9 sound effects, just so you know they're easy. 0 through 9, 0 through 9, for a total of 20. Here are the parts we need to make voice come out of the CNC. We have a propeller, microcontroller, an EEPROM, which will store the propeller's data, and a micro SD card slot that we wired up manually that will hold the audio data itself. So we'll combine these into a small package that we can fit inside the unit. It'll connect to the button assembly that we built, and then hopefully we'll be ready to rock. It'll probably be easier to use this larger propeller just because it's easier to solder. Put the SD card up here and put the EEPROM right in the middle. So it's kind of like a stick. Hey, I know, you and I can be played by Gillian Anderson and David Duchovny. So Gillian Anderson's had to like grow like 8 more feet of hair. Make me hiccup. In the palm of my hand. Ben is in here. He's gone sour. It's now Allison's super cute animal hour because it rhymes. Here is the microcontroller I wired up to give us our sound. I'm using the Parallax propeller. It has 8 cores. It will easily be able to run sounds for us. Then I hand wired this micro SD card because it takes up a lot less space than a full-size SD card. There's the EEPROM. This has the code on it that the propeller loads when it boots. And there's a programming dongle right here, so we can program it from the computer. And then I've added a variety of ports. There's power in, there's flip switch. Flip switch is when this thing flips, so it knows which side it's on. Audio out to the amplifier. And then these are the 10 inputs, 5 on this side, 5 on this side, plus ground. And this indicator light basically just blinks so we know that everything's working. So I'm gonna start getting this built into the unit. We have this button PCB here, and it's gonna connect to our microcontroller through these 2 headers. I like Three Musketeers and Twix, those are my 2 favorites.
Would you rather have a Twix than a Reese's Peanut Butter Cup?
I would rather have a Reese's Peanut Butter Cup. Because Reese's Peanut Butter Cups are good, but I wouldn't consider them candy bars.
But they kind of trump all candy bars.
Well, they are pretty awesome. I think we should do, oh yeah! Going to mark the polarity here. There we go. Just making sure these go together for starters. So this thing, which keeps reminding us of a Twix bar for some reason, it's probably gonna go right about here. So I'm gonna wrangle these cords basically the best way I can. There's some screws here that are metal, and even though there's nothing under that part of the board, I still cover them up with electrical tape just to be sure that there's no short circuits. Guess we can detach this part now. It is time, young Jedi. Gotta make the good fish go bad. Oh, I just thought of something. When I went home last night, I thought I had a Reese's Peanut Butter Cup in my fridge, but it turns out I put it in my sandwich box here at work, which means it's in the fridge. There's only one. Fight. Liu Kang wins. We'll probably want to create a power switch for this as well, but we should be able to use the original 3 batteries, although we'll need to step it down to 3.3 volts. The propeller is not very tolerant of higher voltages. And even if it were, we should still give it the right voltage, 3.3 volts, not 4.5. I've assembled all the parts. Let's do an overview. Here's the custom PCB that we made to replace the one that was in it with the ASIC. Goes over here to this Parallax propeller. Here are our 10 switches plus ground, so we know which one it landed on. There's also this plug here, which goes to the panel switch, basically which panel you're on. So it's 10 positions times 2, so 20 possible outcomes. So we have that all wired up. We have our power source here. I've tucked it down here to make sure there's room for the batteries. We have a 3.3 volt linear load dropout regulator. We have our normal 3 batteries that came with it. I added a switch, basically so we can turn the whole thing on. This original circuit probably had, oh gosh, there isn't even there's hardly anything to this. What they probably did was when you complete the circuit, it turns on everything and then plays the sound. Yeah, we couldn't quite do that with the equipment we have, but whatever. Here's the original speaker. So I have this very simple single transistor amplifier. Basically, you put positive voltage into the speaker, you sync it through the NPN transistor, which is activated by the pulses coming off of the propeller. All right, this is actually a pretty decent little propeller system I made here. It has indicator light, and it's almost like its own little dev board, but now it'll be trapped forever inside this unit. So let's just make sure it works. Fits together. course. It has to say hi when it turns on. Okay.
Get a new email.
Let's try this one. All right, seems like it works, so let's put some graphics on it. All right, now we have the See and Say Dave Jones edition ready to go. So there's 2 different panels, all sorts of different photos of Dave Jones. You know, thinking back on it, I probably should have made this actually educational. Like there could be different symbols, schematic symbols for electronics, and then Dave would say what they were. Then you could have symbols on one side and the photographs of actual components on the other. But I didn't have enough custom speech to do that. Maybe Dave will do some custom speech for us. That'd be cool. But this is still fun. So let's see, switch her on, see what Dave has to say. Oh yeah, so when you switch it on, it says hi.
Hi.
Dave's trademark line.
Spectacular transistor hardware. Give it a go. Catastrophic capacitors.
So if we have the catastrophic capacitors line here, it'll be different on this side.
Unbelievable.
It's just fun to, you know.
Play with this sucker all day long.
I could play with this sucker all day long.
It's pure engineering evil. Unbelievable. Fantastic. High voltage GPS.
There you have it, the Dave Jones See and Say. Beauty! That's all the time we have for today. In our next episode, we're going to show you all the experiments we did to come up with the best way for us to make PCBs for custom projects like this. We'll see you then. Thanks for watching this episode of The Ben Heck Show. If you're looking for extra content, we've just uploaded a tour of my workshop, and it's available now for viewing online. If you enjoy this behind-the-scenes footage and want to see more, please let us know by leaving a comment below. They look like specks of dust, but it's actually ghosts. Let's eat cake. Ray Charles has a song that was like, I wish I could go back to those days again. It's the same song. Will Smith just changed the lyrics.
And I don't have HBO.
If I had to guess, neither do any of your friends. Okay, this is me doing an impression and now you're laughing at it. Oh, that's completely forced.
Patrick, I'm coming up to visit.
I don't have HBO. That's what this is all about. Now you need to remind me and just rub salt in the wound.
Don't forget, you can subscribe to this channel, join the Element 14 community, follow us on Twitter, and become our friend on Facebook.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.